Hey everyone, we are here looking at notes 2-2, solve absolute value inequalities today. So there are some similarities as well as definitely some differences from solving absolute value equations, and we're about to go over those. Before we get to the examples today, I want to go through these two very simple problems. That way we can really understand how to set up these problems as well as how their answers will look. So let's get started. So if you have an absolute value of something, in this case we have absolute value of x is less than 3. So anytime you're working with less than, or if you're working with less than or equal to. So for less than or equal to problems, your solutions will look like this, okay? Where this is truly the solution and this is the shading for that solution, okay? And similarly, anytime you have a greater or a greater than or equal to problem, their solutions will look like this, okay? Where you have this split shaded region, okay? And you have the or in between the answer statement. So this is, like I said, these are really the answers. These are the shading that correspond with the answers. No, I did not misspell greater. Well, I did, but I did it on purpose, okay? Because I will emphasize when I say the word greater, I will emphasize the word or in that because your solutions for greater will have that or in between, and you can think of the shading as this or that. So yes, I know I misspelled it, but it was on purpose, don't worry. Okay, so before I really press on further, I do want to say though that these come with a caveat. So the caveat being that this is only true whenever the absolute value bars are isolated. You can't say that this is true when you start the problem, because what might happen is when you go to isolate the absolute value bars, you might have, say, like a -2 out in front, and then you have to divide by -2. And what happens when you have to divide by a negative and you're working with inequalities? Oh, yes, you have to flip the symbol. So you can't look at the symbol and distinguish what type of problem you're going to have until you've gotten the absolute value bars isolated. So just so you know, that's that caveat for these. Okay, so let's talk. So for this first problem here, absolute value of x is less than 3. Okay, so why is this the solution? Well, think about any value within this shaded region. I'm just going to pick one. I'm going to pick -2. So if I plug -2 in here for x, so that would state the absolute value of -2, what is the absolute value of -2? It's 2. 2 is less than 3. Is that a true statement? Yes. Okay, similarly, I could pick 0. Okay, I could pick any number within this shaded region. I could pick 1.5. I could pick 1.6, 7, 8, 9, 10, whatever. I could pick any number inside this shaded region here, and when I plug it in, that would create a true statement. Okay, now anything outside of the shading, even including the open circle here, anything outside of that shading would produce an untrue statement. So even if I plug in 3, okay, the absolute value of 3 is 3, and 3 is not less than 3, okay? Now, this would be a closed circle, as you know, if this were equal to here, and so would this be or equal to bars if this were or equal to here, then of course the only difference would be these would be shaded in and these would have little lines down here. Okay, so that's the only difference if you have or equal to. But otherwise, anytime you have less than or equal to, you will have a solution that looks something like this, where everything in the shaded region will create a true statement. When plugged in, everything outside will create a false statement. And that's the same reasoning behind why this solution looks like it does. If you pick any number within the shaded regions, okay, that number when plugged in would create a true statement. For example, if I plug in -5, the absolute value of -5 is +5, and 5 is greater than 3. Okay, anything outside of the shaded region or even in the open circles would create a false statement. Okay, so I think that's enough explaining, and let's get to it and practice these concepts. So look at problem number 1, okay? So it says solve each inequality and graph the solution on a number line. Okay, I've provided the number lines. They're not on the assignment, so you'll have to be, I'll explain what I want you to do whenever I don't provide the number line. So let's get started with number 1. So the absolute value bars are isolated, okay? I don't have anything in front, anything behind I need to get rid of. So then I am allowed to look at the symbol and determine, which of these am I going to use? So since this is less than or equal to, it's one of the two of these. Okay, I'm going to choose this setup. So let me explain. So similar to this, what's inside the absolute value bars goes in the middle. So this 2x minus 1 is going to go in the middle. Okay, and then there's going to be less than or equal to bars around that. So again, what's inside the bars goes in the middle. Okay, and then less than or equal to, in my case, because I have the or equal to. Here, I didn't have the or equal to because this didn't. Okay, and then just like here, notice how that's a -3 and that's a +3. This is going to be a -5 and this is going to be a +5. Okay, from here, all you have to do is solve. And I know it looks really funky, but I promise you'll get the hang of it. So for this type, I'm going to actually, here, let me use pink. I'm going to go ahead and do this method where I add 1. So -1 and +1 is 0, but what I do to one side, I have to do to all 3. Isn't that funny? So now I have like 3 sides, I guess, if you will. So now I'm going to add 3 to all, add 1 to all 3 parts. So this is going to be -4, drag down the less than or equal to, the 2x drags down, less than or equal to 6. And now I've got to completely isolate x, so that means I need to divide every single part by 2. Okay, so that of course is going to become just x. That's exactly what we want. And then this is -2 and this is +3. Okay, so now I'm going to take my solution. Here's my solution now that x is isolated, and I'm going to come over here and I'm going to graph it. So -2 is my leftmost dot here, and +3 is my rightmost, and I'm going to shade, of course, everything in between because x lies in between. My possible solutions lie in between those two values, those two endpoints, and I am going to color those in because we are or equal to on this problem. So like I said, if I don't provide the number line, then I'm sorry, you're going to have to get out a straight edge, you're going to have to do your tick marks, etc. But just so you know, I at least wanted to provide them on the notes. But make sure you have pride in your work and you use that straight edge and you make it look real nice, just like a computer one would. Okay, so on number 2, the absolute value bars are isolated, yes. Okay, nothing in front, nothing in back. Absolute value bars are isolated, and now we have greater. Okay, not greater than or equal to, but we have greater. So that means our setup's going to be something like this. This one's a little funky, but I know y'all will get it. Okay, you're still going to take what's inside the absolute value bars. You're going to leave it alone, just like we did when solving the equations. Actually, this method is very similar to when we solved equations, okay? Where remember when we solved equations, we wrote it like out twice. Maybe I should do that. Will I have enough room to solve? I think I will. Let's go ahead and do that. Hopefully you're using pencil, sorry, or erasable pens like me. Okay, so I just want to show you the similarities here. So just like when we did solving equations, you're going to take out the 2x plus 3 from the bars. You're going to keep it the same on both. On this first problem, remember how when we did equations, we changed the sign on this value out here? Same here. We're going to change the sign on the value here. We're going to keep it the same here. Okay, on the one you change the sign on, you also change the symbol. So the symbol changes. Okay, on the one you leave the sign alone for, you keep the sign the same. So this problem looks exactly the same as this, except the bars are gone. And this one, both the symbol and the sign change. So hopefully you're seeing that at home, okay? And then we're going to solve just like we're used to, okay? So the +3 needs to jump. So we'll have 2x is less than -1 minus 3. Okay, so in other words, 2x is less than -4. And I divide by 2 on both sides. Oh, I've been using pink for that, so let me go ahead and stay consistent. So divide by 2 on both sides. Okay, and of course, 2 divided by 2 is 1, so this is just x is less than -2. Now I don't need to switch my sign here. I didn't divide by a negative. Yes, this number was negative, but this wasn't a -2 that I divided by. Okay, you only switch the sign when you divide by a negative number, and that wasn't negative. So this one's good, or we're going to put the or in between. Now let's go go to town with this guy. So it's going to look like 1 minus 3, so 2x less than, this is negative 2. So of course we're going to divide both sides by 2. And this is going to be x is greater than negative 1. So I'm going to rewrite it over here. That way it's more clear. So x is less than negative 2 or x is greater than negative 1. Alrighty, so let's draw our circles. So negative 2, negative 1. Okay, and how do I shade? So with the less than, it's real easy. You just shade in between, right? Here you got to actually look at it. So x is less than negative 2. So less than negative 2 would be over here. These numbers are less than negative 2. Okay, or x is greater than negative 1. So the values that are greater than negative 1 would be over here. And it's just as we suspected. After we decide how the shading goes, we should look at it and say, oh yeah, it does look like that where it's separated. Okay, so we're good to go there. All right, last one. So on number 3, of course, a little more complicated. The absolute value bars are not isolated. So it would not do me any good to look at this less than sign right now and say, oh, I'm going to use that type, because I don't know if that sign's going to change whenever I isolate the bars. Okay, so let's go ahead and start doing that process where I'm going to move over the minus 9. Okay, so I've got this negative 3 absolute value 2x plus 4. Sorry, I'm writing tiny because I'm not sure how much room I'm going to have. Negative 27 plus 9. So, okay, that's going to be 2x plus 4 is less than negative 18, right? And then I'm going to divide to get rid of the negative 3. I'm going to divide both sides by negative 3 because, of course, negative 3 divided by negative 3 is 1. And I don't need to write that implied 1 out in front, hence the word implied. It's implied. Bing, 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 bing. A red crazy noise is going off in my head saying, what just happened? I have to flip my symbol because I divided by a negative. So that symbol flips from less than to greater than, and now negative 18 divided by negative 3 is positive 6. Okay, so now you see what I was saying before. We might have thought it was going to be a less than, but actually now that my bars are isolated, it's greater. So since it's greater, again, I'm going to do the thing where 2x plus 4 is less than negative 6. Remember, on the one you change the sign on, you also change the symbol. And then I'm going to have 2x plus 4 is greater than 6. So now I'm going to move the 4 over. I'm going to have to to save space, I'm going to do this part in our heads, okay? So that plus 4 is going to become minus 4, and that's going to be negative 10, yes? And then I'm going to divide by 2 on both sides, and I'm going to get x is less than negative 10. Oh, hello, no I'm not. I'm going to get x is less than negative 5, okay? That's why you show the steps. Because if you don't, you might skip doing the work. So here, minus 4. So this is going to be 2, yes? Divide by 2 on both sides. You get x is greater than 1. So again, I'm going to come over here and rewrite it just so it's nicer. It kind of got sloppy there. I'm so sorry. Okay, so here's the solution. And we need to graph. So negative 5, we're right on the end there, aren't we? And then positive 1. X is less than negative 5. That would take me in this direction. X is greater than positive 1. And again, of course, I don't have shaded circles because I don't have the or equal to, right? And the problem didn't start or equal to, so. Does this make sense? Great. Oh, right here when the absolute value bars were isolated, it was greater, so that's how our answer should look. All right, y'all have a nice day.